Okay, good morning. So you guys had some homework. The homework was exercise 1.1 and 1.2, no? The first column in 1.2. So let's go to 1.1. In 1.1, any issues with number 3? You had to start from number 3, no? You had to write those numbers in products of its prime factors. No issues. Then you had to do number 8. Any issues there? No problems? No? Then you had to do number 10. Any issues there? Yes, okay. So they say determine two consecutive integers that each irrational number lies between. So the first number is the square root of 50. Exercise 1.1. Number what is this? 10. The square root of 50. Now there's two ways of doing it. I can punch in the calculator. I should get 7.07 something. Not so? Then I know it's between 7 and 8. So say for argument's sake they ask you without the use of a calculator, then I would have said, okay, the perfect square less than 50. The biggest perfect square less than 50 is the root of 49. And the smallest perfect square less than, greater than 50 has to be the square root of 64. Not so? So the square root of 49 is 7. Square root of 64 is 8. Therefore the square root of 50 has to be greater than 7 and less than 8. So it's lying between 7. Make sense? Sorry? Because it just said 7 and 8. B, what was B's question? The cube root of 45. So the question you should be asking yourself, what is the biggest perfect cube less than 45? So perfect cubes are 1, 8, 3 cube is 27, 64, 125, and so on. So the largest perfect cube less than 45 is the cube root of 27. Not so? And then the cube root of 64. So in other words, the cube root of 27 is 3, that is 4. So the cube root of 45 has to be greater than 4. But it has to lie between. It actually lies between. Rather and. Lying between 3 and 4. Makes sense, people? And the last one? Rather could they add, no? Yes? 2 cube root of 6. Square. 2 root 6. So, the biggest, the perfect square, the largest perfect square less than 6. The square root of 4. Not so. But there's a 2 in front. Okay? And the perfect square greater than the square root of 6, the square root of 9. So that is going to be 2 times 2, which is 4. It's going to be 2 times 3, which is 6. It's going to be between 4 and 6. Okay. But, let's just check something. I could have done it this way as well. If I bring that 2 into that, there's going to be 2 root 6. The square, 2 can be written as the square root of 4, not so. Okay? So if I bring this as 1, this can be written as 4 times 6, which is 12. The largest perfect square less than 12. The perfect square less than 12 is going to be the square root of 9 and then the square root of 16. So it's going to be 4 and 3. This is actually wrong. Sorry? 4 times 6 is 24. Yeah, there's my mistake. 4 times 6 is 24, not 12. So the largest perfect square less than 24 is the square root of 16, which is 4, and 25, which is 5. So that is actually good. So it's between 4 and 5. So because I didn't take this into that square root, that is why I picked that up. So it's going to be safer for you to do this and not apply this method. It'll be better. Otherwise you put in the calculator and you say 2 root 6 and you'll see you'll get 4 point something. You will definitely be between 4 and 5. Make sense, people? Okay. Any other issues with regards to exercise 1.1? No? Then we go to exercise 1.2. You have to do the first column. Any issues in number 1? Sorry? No. Okay, number 2. Sorry, I thought you were grade 9 earlier on. When I sent you to the prefab for the assembly. Sorry. You're grade 10 this year. Congratulations. Okay. Any issues with number 2 in this column? Yes, Michael. M. Any issues other than M? Okay, for homework, you're going to do for me exercise 1.2, number 2, I, L, and N. I, L, and N. Okay, so number 2, M is the issue. The question says you must simplify, got a half x plus a third y multiplied by a third x minus a half y. Okay, what did you do? Distributed below here and multiply it out. The foil, yes. So what did you get for the half x times a third x? 1 over 6x squared. So what did you get for half x times negative half y? Negative or positive? Negative 1 over 4 xy, which is correct. So what did you get for a third y times a third x? Positive 1 over 9xy, yes, which is correct. 1 over 6y squared, which is correct. So what do you do after this? Okay, now if you look at that, what do you see? Is it like this? Yes. What makes them like The variables are the same. The xy, there's the xy. That what makes it like. Not so? So now you put in your calculator negative a quarter plus 1/9. Put your calculator. Five over 36 xy minus 1 over 6 y. Sorry? So you found the LCM as well? You can do LCM, no problem. So you didn't do this step here? But you went further. No problem. What's your LCM? 36. So you times it by 9. So you're going to get your 9x squared times by 1. Negative 5xy. Multiply that by 6. Negative 6y. So is that what you got? You got that correct in this one? This one? But you didn't get this. But you found the LCM. So you must have made a mistake here, son. So what do you have? Exactly the same as this here. The same as the blue. But you found the LCM. So you only found the LCM for the light terms. So you got, so what you have, so read what you have. Yes, as your answer. 1 over 6x squared, which is correct, yes? Minus 5 over 36x minus 1 over 6x. So why did you say I must do? So is this not the answer in the book? What's the answer in the book? Oh, okay. This here and that is equivalent answers. It's the same. Both is correct. So in the exam, if you had left it like that, you get the mark. Alright? You what we call equivalent answers. Like for argument's sake, if you have it as a final answer x minus y, but the textbook's answer is minus y plus x, the answer is correct. Okay? This is what we call equivalent answers. Okay. Any other issues? No. So now we're looking at squaring of binomials. Okay. And we are on page 8. Squaring of binomials, page 8. There are two sums there. I want you guys to do it quickly. I think we did something like this last year already, not so? What do we have to do first? Write it out twice, and then you multiply them. Not so? So do that quickly. Hereafter I'll show you a short method. Right, so what would we have done? We say so it would be a plus b times a plus b, not so. So what do we get now? A squared plus ab plus ab plus b squared, not so. So what do we look now for? Like terms. So it's going to be a squared plus 2ab plus b squared. That's all. Guys, finish with the next one already? Yes? Look at this here. A minus b times a minus b, which is simply a squared minus ab plus, no, minus ab plus b squared, which is a squared minus 2ab plus b squared. That's it. I was going to show you a shortcut method. Let's just do the next two before we go into that. Let's do those two quickly. Okay, again we write this out twice. X minus 3y, x minus 3y. Okay, we multiply this out, I get x squared minus 3xy minus 3xy plus 9y squared. Okay, which now gives us x squared minus 6 xy plus 9. Okay, the last one here, write it out twice. Multiply that out, I get x squared minus 6xy minus 6xy plus 12y squared. 36. Absolutely. Which now gives us x squared minus 12xy plus 36y squared. You all agree with that? As I said, there's a quicker way of doing it. Let's look at the first one. So you got a plus b all squared. And this works for any binomial all squared. We square the first term plus the first term times the second term times 2 plus the last term squared. Can you see the link, people? First term squared, last term squared, and the first term times the second term times 2. Can you see that? So what will this give us? A squared plus 2ab plus b squared. You all see it? Let's look at this one. A minus b all squared. Square the first term plus first term times the second term times 2. But the second term is negative here, don't forget. So it will be a times minus b times 2 plus the last term squared. So what will that give us? A squared minus 2ab plus b squared. So what you notice, that even if it's negative, the last term is always going to be positive. You will see that. If this is positive here, the middle term will be positive. You see that? If it's negative here, the middle term is negative. Does it make sense? So what's the rule? Square the first term, then the middle term, it's going to be the first term multiplied by the second term times 2. The third term is going to be second term squared. So let's write that down. For any binomial square, so let's make that note. For any binomial square, you can do the following. So it will be the first term squared. So number 1 is going to be the first term squared. The next thing is going to be for the middle term. It will be then it's the first term multiplied by the second term multiplied by 2. Thirdly, it's going to be the last term squared. It will always be the last term squared. So what I want you guys to do is, as I apply that rule to those two sums, I want you guys to do that rule to the next two quickly. Okay? Number 3 and 4. Okay. You guys finished? Still busy? Okay. So what's the rule? First term squared. Not so. What's the first term squared? X squared. For the middle term, so it'll be first term times the second term times 2. So what do I get? X times negative 3y times 2, negative 6xy. Last term squared will be negative 3y all squared, which is positive. Okay, you all got that right? Anybody made a mistake? No? The next one, first term squared, it will be x squared. It's going to be first term times second term times 2. In other words, it's going to be x times negative 6y times 2, which is negative 12xy. Then it's the last term squared, which is positive 36. You guys understand? So instead of doing 4 lines there, I can do 3 lines, sorry, I can do just 1 line. So fine. Right, you guys understand?